Hey, today we're going to look at how to find the derivatives of general, exponential, and logarithmic functions. And we'll start by finding the derivative of a to the x, where a is any positive real number. And here's the main trick, and we're going to use it over and over again, so we may as well take a moment and make sure everyone understands. It's to take a and rewrite it as e to the natural log of a. Well, the exponential function e to the x and the logarithmic function, the natural log of x, are inverse functions. So you can think of it as, the reason this is true is simply because they're inverses. Or you can think of it as, what is the natural log of a? It's the number you would raise e to in order to get a. Well, take e and raise it to that number, you better get a. So think about that for a few moments if you need to. Play it over again. Make sure you understand because it's going to come up more than once today, and it's really important to know. All right, moving on from there. Since a is e to the natural log of a to the x is e to the natural log of a to the x, which is just e to the natural log of a times x by the properties of exponents. Returning to our consideration of the derivative, that makes the derivative of a to the x the derivative of e to the natural log of a times x. And this is just a chain rule problem. We know the derivative of e to the x, it's just e to the x. Here we have e to some function. So to take the derivative of e to that function, we treat the function like it was a variable and get e to that function. And then we have to multiply by the derivative of the function that we just treated like a variable. Well, what's the derivative of natural log of a times x? Natural log of a is just some number. And so you take the derivative of natural log of a times x the same way you would take the derivative of 7x or 94x. Which is to say, you just get natural log of a as the derivative of natural log of a times x. And since, as we've already seen, e to the natural log of a times x is just another way to write a to the x, we get a to the x times the natural log of a. And so what we've just done is come up with a formula for the derivative of a to the x. It's a to the x times the natural log of a. So for example, the derivative of 7 to the x, 7 to the x times the natural log of 7. Even more interesting, you say to yourself, e is a real number that's greater than 0, so why wouldn't I be using this rule for the number e? I've got a special rule for the number e. This rule gives that the derivative of e to the x is e to the x times the natural log of e. And the beauty here, of course, is that the natural log of e is 1. And so, happily and not surprisingly, we get that the derivative of e to the x is e to the x. In other words, this rule is a more general version of the rule that we already had in place for the specific case when the number was e. This rule works for any positive real number. Okay, I want to move on and use similar techniques to try to compute the derivative of the natural log of x. And the trick here is going to be to write x as e to the natural log of x, just like we wrote a as e to the natural log of a in the last example. And the beauty in this case is we know the derivative of x is just 1, and so that tells us that the derivative of e to the natural log of x is 1, because e to the natural log of x is just x. And of course, the fun doesn't stop there. We know how to take the derivative of e to the natural log of x. You have to use the chain rule. You treat the natural log of x as if it were a variable, and the derivative of e to a variable is just e to that variable, so we get e to the natural log of x, and then we have to multiply by the derivative of the function we just treated like a variable, which is to say, multiply by the derivative of the natural log of x, which is the thing we're trying to figure out. And we know that this is equal to 1. From way back here, we have that e to the natural log of x is just another way of writing x. And so we have that x times the derivative of the natural log of x is equal to 1, which gives us our answer. The derivative of the natural log of x is 1 over x. Take a moment, appreciate the beauty of that. Quite the elegant result. Okay, we've done the derivative of a to the x, where a is any positive real number. We've done the derivative of the natural log of x, which is the log base e of x, we may as well complete and round out our study today by doing the derivative of the log base a of x, where a is any positive real number. And we do it in a very similar way that we found the derivative to the natural log. We write x as a to the log base a of x. And since the derivative of x is 1, that tells us that the derivative of a to the log base a of x is also 1. And we know how to take the derivative of a to the x. We just figured that out today. So that means we know how to take the derivative of a to some function. You have to use the chain rule. You treat the function as if it were a variable. And if it were the variable, then by our first rule that we came up with today, we would get a to that variable times the natural log of a. And then you finish the chain rule by multiplying by the derivative of the function we just treated like a variable, which was the log base a of x. So we have to multiply by the derivative of the log base a of x. And as before, this is equal to 1. And then once again, we use the idea that a to the log base a of x is just equal to x, giving us that x times the natural log of a times the derivative of the log base a of x is equal to 1. And finally, if you divide both sides of that by x times the natural log of a, you get that the derivative of the log base a of x is 1 over x times the natural log of a. Okay. Here are the 3 differentiation rules that we came up with today in the order in which we derived them. And they're all important to some degree or other, but they're not all important to the same degree. In particular, this little beauty in the middle, the derivative of the natural log of x is 1 over x, ridiculously important, going to show up every time you turn around. There is no way that you can get through calculus without knowing that derivative rule. So commit that one to memory and expect to see it a lot. Very important. This one over here, that the derivative of a to the x is a to the x times the natural log of a. Well, it's reasonably important. You'll see it now and then. It'll show up on a homework problem or maybe a worksheet now and then. There are certainly some teachers who will expect you to have it memorized. I'm not one of them. On a quiz or an exam, if I put 7 to the x on it, that's really pushing it. This is something that I would expect you to know that you've seen and, realize that you could look it up somewhere if you needed it and call that good enough. On the other hand, I will emphasize other teachers will feel differently. And so go on to take Calc 2, for example, with someone else, and they might expect you to know this rule. That's also not unreasonable. So it's not that hard to remember, and you probably can. It's just not as important as the others, and you won't see it that much from me. And then we come down to this last one here, the derivative of the log base a of x. And personally, I feel like if I asked you to memorize that one, that would be cruel and unusual punishment. Again, other teachers will feel differently and might expect you to know it, but I will not. It probably won't even show up on homework. We just did it because it's not hard to do and follows the same techniques as you needed to find the other 2 derivative rules. And you may as well have seen it, and it's not that hard. But what you should get out of it is if you ever need to know the derivative of the log base a of x, it should ring a bell. You've seen it before. Easy to look up, and this is what it is. I'll say it one last time and then I'll shut up about it. This one in the middle is the one that you really need to pay attention to. You need to know that the derivative of the natural log of x is 1 over x. And it's probably worth doing one lightning fast example. Take the function f of x is the natural log of x cubed plus 5x squared plus 1. We're now in great shape to take its derivative. It's a chain rule problem. If it was just natural log of x, we'd have 1 over x for the derivative, but it's not. It's the natural log of some function. So by the chain rule, we treat that function as if it were the variable, in which case the derivative would be 1 over that variable, and then we multiply by the derivative of the function that we just treated like a variable. And the derivative of x cubed plus 5x squared plus 1 is 3x squared plus 10x. And after we clean it up a little bit, we get this as the answer, 3x squared plus 10x over x cubed plus 5x squared plus 1. Okay, we have now added the natural log as well as the log with arbitrary base and the exponential function with arbitrary base to the set of functions whose derivative we can take. There's another chain rule homework up, and it's got lots of problems, and the basic difference between this one and the last one is that the natural log shows up everywhere in most of the problems so that you can practice using it in the context of chain rule derivatives. So work on that homework, have fun with it, see you in class, bye.